as you can see, distribute lists are very, very powerful. However, their power comes from the mechanisms that are being utilized to identify the routes that you want to control. And in our examples, we used access control lists. If we go back to our example, you'll notice that the access control list says permit this particular range of addresses. Do you see a potential problem here, folks? By just defining a range of addresses. Is there something missing that's really important that is included in our routes? Think about that. If you're not sure, let me point to it. What is that? That's a subnet mask. Does the access control list identify a subnet mask? Be careful how you answer that. It doesn't. It doesn't. Look at the access control list. It says this address range from 10.10.11.0 through 10.10.11.255. So what if the route was 10.10.11.0/26 or /28 or /30? Would it be redistributed in this example? Yeah. Because it still falls, the address falls within the 10.10.11.0 through 10.10.11.255 range, regardless of what the subnet mask is. So we may want more control. And if we want more control, we need the ability to define that subnet mask, saying this specific address and this specific match. And that's where the prefix lists come into play. So when we look at this example here, we are creating a prefix list in global configuration mode. IP prefix list. We are giving it a name. PFL. You can name it whatever you want. It's better to be descriptive. For example, if you are trying to filter certain routes from a particular neighbor, or you are trying to filter routes that are being redistributed, you might want to be descriptive with the name, so that way there, when you look back at the prefix list, or you are troubleshooting the prefix list, you know exactly what the prefix list was created for. You're stating permit. You can also say deny. We will look at the differences between permit and deny in a prefix list, as well as route maps coming up and how they affect redistribution. But it all depends on what you're trying to do. For example, if we are applying this just to a distribute list to filter routes that are being exchanged between EIGRP neighbors, or routes that are being installed from the link state database into the routing table for OSPF, well then permit says share that with the neighbor for EIGRP, or install it in the routing table for OSPF, and deny would mean don't share it with the neighbor and with EIGRP, and do not install it in the routing table for OSPF. So it all depends how you apply it and what the purpose is. And then in this case, notice it says 10.10.11.0/24, 10.10.12.0/24. So what happens if there's a route in our routing table for 10.10.11.0/26 or /28? Well, it's denied. Now, why is it denied? Because of the invisible implicit deny all rule at the end of the prefix list. Just like the access control list has the implicit deny all, so does the prefix list. So how is a prefix list processed? Just like an access control list. What do we have? We have top-down processing. Number one. Number two, immediate execution. Immediate execution upon a match. So we look down the list, top down, find an entry, bam, we hit it, we process that. If we don't find an entry at all, No entry whatsoever that matches. What happens? Deny. Just like what? Just like access control lists. We verify our prefix list with the show IP prefix list command. In this case, PFL. Notice they're sequenced. Sequence 5, sequence 10. If you don't provide a sequence number, notice there's no sequence number here whatsoever. So since there's no sequence number, it gives it a default of 5 and increases by 5 every single time. But there's our 2 entries and the implicit deny all at the end. You don't see it, but it's there. Always remember that it's there.